Okay, couple of things before we begin about now that you're actually, most of you have your GitHub repositories going, and you have the GitHub repositories in your computers on Matrix and on GitHub. GitHub, don't touch anything, don't start editing stuff on it. You can edit anything on GitHub too on the browser. Go on a browser and do it, but it's better not to do it, number one. Number two, when you actually create a repository, and the repository, the Git application starts looking after your files, when that happens, then because of the fact that now Git is taking care of your files, you should not use the operating system file management to change your files, which means you should not delete your files using Windows. You should not try to delete your files using Linux on Matrix or your terminal on Mac. If you want to delete a file, you have to ask Git to delete it. If you want to rename your file, you have to ask Git to rename your file so it can keep track of the changes. For Linux, it's very easy, and for Mac. The command lines that you have for deleting, which is rm to remove, you just say git rm instead. If you want to change the name, it's mv to move, right? Rename and move is the same. So instead of writing move to rename a file, you do git mv, okay? So all these changes, and if you are renaming something on, so the ones that I told you is on Mac on Matrix, because Mac and Matrix, potatoes, they're the same, right? But if you are actually dealing with files on Windows, either you can use the command line and go with Git and do that, or if you want to change something in your repository, what you do, say for example, I want to, oh, this is for today. Let me not change this. Let's say in here I want to write overload. I want to make it overloading. If you do that, you right click, you go to Tortoise Git, because it doesn't show you, you go more options. That's stupid thing about Windows 11. I don't know who did that, but anyways, now you can go to Tortoise Git and go rename. You see that? Or if you want to delete, you can delete. If you delete like this, it will delete it from the repository and the file. But if you delete with the second one, it will delete repository, but it will leave it as a local file on your computer. So if you don't want to track something anymore, if you don't want to track some file anymore, you go delete but keep local, which means it deletes it, but it stays on your hard drive. But if you just say delete, it will delete it from the repository and the file. And if I want to rename, I click on rename over here, and I simply go overloading, okay? And when you do that, then it will actually change. Now you can actually commit your change. So when you do the commit next time, it will be renamed on the main repository too. So if I go over here and say Tortoise Git commit, you will see that in here it says, you see that? Overload, so it says it's from this to that, rename. So it actually shows that. And I'm going to select the rest of the stuff, and I'm going to say Jan 14. So now that rename is going to actually go to GitHub, and if I'm on Matrix and I'm pulling it, it's going to go to Matrix. So something you need to realize, let me just do something in here, just a second. Yeah, so something you need to learn. I know it sounds like hassle a little, but believe me, you're going to thank me later for it, which means have your master repository, which is your GitHub. We call it upstream. In industry, they call it upstream. So you see fish swim upstream, okay? That's why they call it upstream. So upstream is your master repository, okay? Use that as your upstream, and any change you do, you push in that one, then you can pull it everywhere else. So that's how the files are supposed to get transferred from one platform to another platform, from one computer to another computer. Now, I asked them to install Tortoise Git on my apps, on your lab computers. I don't know how it's going to work. I have to test it myself first and then tell you. But now your computers have Tortoise Git too. But I think to do that first, you have to install Git too. So on my apps, you have to install Git and then Tortoise Git. But I'll test it myself, then I'm going to have an announcement on that. But again, please remember, do not change your files using the operating system anymore. Change your files using Git. Next thing I wanted to mention, any trouble, this is now the beginning of working with Git, so you're going to have conflicts. And you'll see what is that. When you are pulling something, suddenly you see it gives you a conflict. It means I could not merge the changes. If that happens, you can contact me and I'll fix it for you. And you can always, I gave you a book to read, okay? I know reading is against everybody's religion these days. You don't read, people don't read, but reading books is good, believe me. So it's an open source book on Git, and I told you read chapter 2 and 6, I think, something like 1 and 2. They're like 30 pages each, 30, 40 pages each. You read that, and everything's going to get crystal clear. And one thing I have to tell you, I know a very few people who know how Git works, and I'm not one of them, okay? So it's a very complicated system for version control, but you can always use it at the kindergarten level. That's what we are in, okay? And if something happens, we'll fix it, okay? Keep that in mind. So for those who did not do Workshop 0, no worries. I'm going to add an extension to it. So as you can, actually it's easier like that. Send me a message on MS Teams and tell me I haven't finished it, and I'm going to give you an extension. So as soon as you get the extension for it, then you will see that it's going to remove the restriction to be submitted from the lab computers. Then if you couldn't do it, ask me for help, okay? What I like to see what the students do is that they attempt and they can't do it, and I help them. What is disappointing for me, for somebody who tells me I need help, and I'm going to come and help, and I say, did you do workshops here? And say, yes. And I look at it and I see they didn't do anything. Or they don't do it and they want help. That doesn't make sense. You have to first try. Fail in it, then ask me to help you, then you'll learn. If I do it for you, what's the point? So please, I'm ready to help anyone who wants help, but please first attempt it yourself, okay? The reflections are always done a night or two after the due date of any workshop. I think 2 days after, I don't know. When is it due? Anybody knows? If I don't know when is it due for reflection, but and I don't have to do a submission, I put -2 at the end and tells you when the due date is. But reflections are done few days after you submit your workshop, because I really want your reflection. I don't want you to just ask ChatGPT to write a paragraph for you and cut and paste it for me. Okay, I want your feedback on it. This was hard, that was this, I don't want this, I want that. This is vague. I want to see these things, okay? Reflection is really reflection. I want to see what's going on. Anyways, we're good?
Excuse me.
Yes.
Where can we find that book that you were talking about? The book that you were talking about?
I think if, let me see. Give me 2 seconds. Give me 2 seconds. I think it should be here. If we go to Blackboard, OOP244NBB. There you go. You see over here, the URL of this book is, where are you? You see this? GitHub organization, yada, yada, yada. And it says, to learn more about Git, read chapters 1, 2, and 6 of the Git open book. These chapters cover essential yada, yada, yada. The URL for this book is such and such. So it tells you what the URL is. Okay? And the easiest way is this. Open Git book. And seriously, there you go, Git book. You see that? And you open it, probably that's the one. Yeah. Welcome, quick start. It goes through everything, so you can actually go. This is, I don't know if this is the one or not. I hope this is the one.
Because the link that you put that one on is not working.
It's not working?
No, it's not.
Oh, so that was an old one. So they updated the link. I'll go through it and see what's going on.
No, I think it's working.
It's working?
Yeah.
Oh, somebody says it's working. The other one says, so
Just copy and paste this. There says the page doesn't exist.
okay, let me check it out. You know what? Should I put it in Workshop 0? I don't know. I'll put it in the resources. I'm going to create one in the README file of the.
It's working. There's an extra dot.
Oh, it's extra data. Okay. Okay. So, can someone send me that link to if you have Microsoft Teams, can you send that link to me via a message?
What, like the books?
Yeah, the book link. So OOP244. You send it?
Yeah.
Ah, there you go. Thank you. There we go. So now we have the open Git book over here, and we open. So there we go. Yeah, that's what I'm talking about. Thank you. Much appreciated. So yeah. So it talks about it, you read these things, you know exactly what it is. Now, if you keep going and reading it to the end, then you got to come and teach me what Git is. And believe me, understanding what Git is upside down is a huge advantage for your future of computer science programming and your career. Okay? So, anyways. We're good? Yes, sir. You have a question? You have a question? With the New York hat? No? Yankees hat? No? Okay. All right. So, now that that's out of the way, I have to actually pull this because let's Git pull. I changed that link. I have to pull it. There we go. Okay, now it's updated. I'm going to open the things we talked about last time, quickly go through it. So before we begin, any questions about anything, any part of the lecture? Okay, did I tell you about curve of forgetting? No. Okay, there's an old research done on human memory, how we can actually retain information that we have and keep it without losing it, okay? And this is the things that I say over here, and I say this is fact, It means I checked it 50 times. I read 50 papers about it. I'm not, 50 is a lie, but I read the paper. Let's put it that way. So it's not like I went on a TikTok cat video and I saw somebody said it and I'm going to. So it's real. So this is real research done on human memory. And this is how it's done. So essentially what, and you can Google curve of forgetting and you can read the paper and research yourself. So essentially for each lecture that you are getting per day, okay, for let's say an hour of lecture that you have, you need to spend around, I think it was saying around 10 to 20 minutes to review it, same day, not the next day, okay? Then a week after, review it for 10 minutes. Then a month later, review it for 5 minutes, and it's committed to your long-term memory. You will not forget it, okay? You get the lecture today, because the reason it says today, I say today, is that when you sleep, when you go to sleep, your short-term memory is imprinted into your long-term memory. If you don't review it the same day, it's gone. As easy as that, okay? So if you don't review it the same, and when you do review, you're gonna come up with questions. I don't understand this, I don't understand that. Hopefully, you will have a physical paper to write your questions on and bring it instead of those damn computers that all you have. And from a paper, read it for me. I am not a dinosaur. I am very much up to date with all the technology and I'm a geek to the bone, okay? I'm telling you, screens and keyboards don't register in your brain. They're just distraction. Have paper notes and pen to write your questions and things. And if you hear me giving you an answer, jot it down. I know it's difficult the first 2 weeks. I know that. Because I had to switch, like 10 years ago, I had to switch when I found out that I cannot remember anymore. Like I thought I'm getting old, but then I found out it's actually the screen. It's not that I'm getting old. I thought that if I type something, a question, I'll remember it, or if I type something, I'll remember it. But you don't know, typing is completely muscle memory. It's not from your brain, it's from here. So when you're typing something, it's like you're breathing. Do you remember that you're breathing? No. It's muscle memory. But writing is not. Writing, you have to translate that knowledge into analog movements to your hand and write it down. You have to pay attention. And that's why it's going to be committed to your memory. So that's, again, my humble suggestion. Anyway, so no questions? We good? All right. So the person who has a microphone is going to answer the question that I asked later. You know that, and we're going to go through it step by step. So the first thing that I'm going to talk about over here is that, and I want your opinion. You don't want you to lecture me. I just want your understanding of things that I taught the other day. Yeah, I'm not trying to put you on spot. If you're not in a mood, you simply say pass, and you give the microphone to the next person. And if 3 times you hear that, the microphone moves to whoever wants to answer. Are we clear on that? Beautiful. So what's your understanding of a pointer? What is a pointer? If somebody tells you what is a pointer, what would you say?
Like a reference?
A pointer is a reference. Pass it through. So a pointer is a reference. It's a when you say a pointer is a reference in IPC 144, that is a very good answer. Okay? In OOP244, because we have something called a reference, then it becomes confusing. When we say reference in English language, essentially means something that is referring to something else, right? Which is essentially pointing to something else. Therefore, reference, good choice of words, but in C world, not in C++ world. So, what do you think a pointer is? Not using the word reference. I know it's a reference that.
Pass.
Pass, good. My lady?
It's like a variable that holds an address.
Thank you. First thing was amazing. Pass it through. It is just a variable. A pointer is a variable. A variable can be set, a variable can be reset, a variable can be read. Do we understand this? So a pointer is a variable. What do we put in that variable, milady, the next person? So the pointer that she said is a variable. What does it hold? An integer holds an integral value. A double holds a floating point value. A pointer holds anything that comes to your mind, or you can say pass. You don't need to worry about answering.
I was gonna say address.
Fantastic. It's beautiful. Thank you. Are you up for walking?
Huh?
Are you up for walking?
For walking.
Yeah, can you give the microphone to the lady over? Thank you very much. Sorry. So next time, don't sit at the edge of the table, because usually people at the edge of the table are going to move. Okay? So a pointer's job is to hold, it's a variable that holds an address. Now, because we have different types of things in memory, we need to make that pointer, which is essentially an integer. It's an unsigned integer that holds an address. So what is an address? When we say address, what do we mean? Can you elaborate? Like if like a 7-year-old comes and asks you, what is an address? What would you say? An address is? The simplest that answer, not technical.
Just the location.
A location, pass it through. Location is fancy. Location means what? 32 Young Street? No, that's not a location. So location is correct, but it's fancy. In a simplest term, what is an address in a computer?
A place in memory.
Thank you. Pass it through. It got even fancier. Okay, not a place in memory. What is an address when we are talking about a pointer? It's a... Everybody's thinking complicated. I'm trying you to go to basics. Who said that? I'm going to penalize you next time when you talk. You have to raise your hand if you hear 3 passes. Don't go over the rule of the game, please. Yes, it's a number. Pass it to the next person. It's a number. So a pointer is nothing but a number, okay? But that number has a specific feature. Like, it cannot be any number. Like 3.2 cannot be a pointer, right? So what do you think that pointer is supposed to be? What type of number?
A specific number?
Pass it through. You should be a politician, my friend, giving an answer without giving any information. So you have a very good career in politics. So when you ask somebody, they answer you something, but they don't answer anything at all. So what is the characteristic of a number that represents an address? What do you think?
Pass.
The memory location?
It is a memory location. Thank you very much. And again, we are getting 5 answers with 0 information down to this point. It's a specific number. It's a memory location. I want to know what number can represent a memory location. And if you answer, I'm going to kill you. Okay. Pardon?
Integer?
It is an integer. Pass it through. But it's a specific type of integer.
Hexadecimal?
Pardon me?
Hexadecimal? Is it?
Perfect. It's hexadecimal. Pass it through. Okay. Okay. Is there any number that is not hexadecimal? Name one number in computer science that is not hexadecimal. So of course it's hexadecimal. So essentially, again, I'm getting all the same things again. What type of hexadecimal number should it be?
Long integer.
And please use your opera voice. I'm very bad in hearing.
Long integer.
Long integer? Not necessarily. Pass it through. It depends on your platform. Long integer, it means 8 bytes. 8 bytes means 64-bit, which means a 64-bit platform. If my platform is 16-bit, it's like a small computer, then it's actually a short integer. So no, but again, what type of long, long, or short integer is supposed to be?
Unsigned.
Thank you. You just got 2% for midterm.
Thank you.
Okay? Remind me of that. All right? So, and these things that I give, I say 2% for midterm, I really mean it, which means when I marked everything, you tell me, Fardad, remember I got 2% for midterm, and I add 2% to your mark. So those people, so I kind of bribe you to think. Okay? So these are the bribes. I'm not going to give it all the time, but I'll do it every now and then. Not for people who jump through the thing line, but yeah. Okay, we're good down to this point. It's an unsigned integer. Why is it an unsigned integer? Because it cannot go negative. You cannot say byte number minus 32. It doesn't make sense. Okay? So it's an unsigned integer. Okay? Beautiful. So it is an unsigned integer, but because the compiler needs to know what is sitting at the destination, unsigned integers are all the same size, right? So if my computer is a 64-bit platform, then the address is 64-bit, which is a long, long integer, as the lady said over there, an unsigned long, long integer. So the address of a character and an address of a long integer and an address of a double and an address of a car and an address of an employee and an address of a student, they are all 8-byte integers. There is no difference. So address is address. The size of address is different. The only difference is that what is sitting at the target. And because of that, I made that stage and I showed you we cannot just say pointer. We have to say what type of pointer? Integer pointer. So integer pointer essentially means this integer variable that is a pointer can hold the address of any other integers. If I say an employee pointer, it means this unsigned integer variable who's a pointer, which is a pointer, can hold the address of an employee, or what did I say? Employees, I said? Oh, employee, yeah, whatever. So it doesn't matter what is sitting at the target. The size of the pointer is always the same, but the types differ. Are we good? All right. So, coding. Using the force. Okay, come on. Up. All right. Okay. All right. So the reason that I put so much stress on pointers is that the computer science is all about managing the memory, and we need to understand that, especially when we're going to 3, 4, 5. So I want you to have a strong base on it. I know we already talked about references and stuff like that. So I'm just going to mention the pointers and be done with it and talk about array of pointers, and then we can continue, okay? So we know exactly what a pointer is. I said I can write over here double pointer P, and I know that P can hold the address of any double number. We good? All right? Now, if I have over here something like integer, like if I have over here something like if I have a struct employee and I create an employee over here, okay? If I want to create an array of employees, what do I do? I simply have the type, and I'm going to add how many I want after that, right? In here, I'm going to say I want 30 of them. Correct? Now I have 30 employees, correct? We know that. Now if I want an array of double pointers, all I need to do is the same. That means I have 30 pointers that can point to an array, that can point to 30 different pointers all over the place. You follow what I'm saying? Okay? So essentially, what it means is that each element of this is an individual pointer and acts like one. You have to just think about it that way. Okay? What are the uses of this? Let's say you have an array of grades, okay? Or GPAs. You have an array of GPAs. And it has a specific index that is matched with the index of the students, right? So you have an array of students, 50 students, and you have 50 GPAs. So GPA 0 corresponds to student 0. GPA 1, student 1, and it keeps right down to 49. Are we okay with this? Now if I told you, I want you to sort these GPAs so I can see from the lowest to highest so I can get an idea of what the GPA status is between these 40 students. If you sort the GPAs, then you're going to lose who has what, right? Because if you rearrange the GPAs in here, what's going to happen? Then you have to rearrange all the students too, right? You don't want to do that. That's too much data. So what do? You create an array of 50 GPAs, but pointers. And you make each pointer pointing to the array of GPAs. So now you have an array of GPAs, and you have an array of pointer to GPAs, right? So it means pointer 0 is pointing to element 0. Pointer 1 points to element 1, and it keeps going like that, right? Now to sort the array, instead you can sort the pointers, which essentially means you rearrange the array of pointers in an ascending order from their target value, and you're going to have a new order of GPAs without modifying the destination. Because now the pointer is like as if it's a very simple process. It's a trick kind of a thing. So essentially, if I have series of pointers, so let's say I have 3 pointers like this. These are pointers. And these are the values the pointers are pointing at. Right? So if the first one is pointing here, second one pointing here, third one pointing here. Now if I display the first one is shown. If I display the second one is shown. And so on and so forth, right? If I want to reverse this order, what can I do? I can simply make this one point to that one, let this one be here, and point this one over here. Right? Now if I show the first one, the last one is shown. Second one, this one is shown. So as you see, I changed the order of the target values without changing them, just with pointers. It is much more efficient. Say you have an array of schools. A school is a huge concept with lots of data in it. If we want to sort all the schools in Canada, you know how big of a data it is? If you actually want to sort it, it's going to be extremely time consuming to copy and paste everything over and over and rearrange that one. Instead of that, you create an array of schools that is pointing to those ginormous objects. Each array is only 8 bytes, right? Each pointer. And then you rearrange the pointers, as easy as that. So you don't have to do that. That's what array of pointers are good for, and many other things. But this is the best example with our level of knowledge. So essentially, my example would be I can do this. Universal initialization. We'll teach this in OOP345, but I don't know why I'm not going to teach you now. Anything you want to initialize, put a curly bracket in front of it and do it. You don't need assignment anymore. Okay? If you want to write like initialization, not setting. So if you want to say, if I want to have an integer, you can simply say integer I 0. That means I is 0. And the universal way of having something to its default value is this. If you do this, whatever is the default value of that one, which is 0, that's the case. So you don't need to. So this is universal way of initialization. Just know it. All right, so now I'm going to say over here it's going to be, say, 1.1, 2.2, 3.3, and actually let's do it like this. I'm going to put, and I'm going to put over here 4.4 and 3.3. Okay, and let's put 2.2 here and 1.1 here. Okay, now if I want to go upwards, what do I have over here? I have to put address of nums 1, that's the smallest one, right? Address of nums 0, that's the next one. Then address of nums 3, and then address of nums 2. This is the array going up, right? I can do the exact same thing over here. So without changing the order of nums, now I'm changing the order. So in here I'm going to say address of nums 2, address of nums 3, address of nums 0, and address of nums 1. Now I can say 4, I less than 4, and I plus plus. Why did I miss the first argument? Because it's already up there and 0, right? I don't need to do it. So in here I'm going to say cout, target of up, I, and L, and cout like that. I'm going to say 4, I equals 0, I less than 4, and I plus plus. And I'm going to say cout down I. So without changing the order of nums, I can actually create something like this. Have you studied databases yet? No databases, SQL statements, nothing, you know, for now? No, you don't know? Okay. All right. So you see that? So you're going to learn later on in databases that you can actually create what we call views. So when you think about it, an up view of nums is this one without changing nums. This is a down view of nums. So I'm viewing nums in a downward position, and I'm viewing nums at a, so they are all the same, okay? Now you can have actually two different types of pointers created for this. You can, if you are worried that by mistake you are going to change the target, you can always make these constant, you know that, right? You can do it like this, which means this is a read-only view of that, which means I can, when I'm going upwards, I cannot change them by mistake. I'm just looking at them that way. You can do it. You can always change the values, there is no problem, but you cannot change the target. Okay? We're good? Are we okay? That's it. So that's an array of pointers. An array of pointers are very useful, especially when you want to deal with names and stuff, because anyways, well, doesn't matter. We'll talk about it later. We're good down to this point? All right. So that was the array of pointers that I wanted to talk about. Now let's take a look at what we have. Types, overloading references. I want to see what's missing. I think that's what we have. That's what we need for the, oh, I should actually update the addendum too. If somebody send me an email, a message on it, I would really appreciate it. To update the addendum. So I put this semester's addendum up. It's pointing to last semester. Where is it? Course information. Log in. So for week 1, week 2. Yeah, so that's the only thing. Dynamic memory allocation is for the next one. Okay, so fundamental types, we talked about it. We know what they are. Fundamental types are what's coming with the language. And then we have compound types are essentially structures. Any structure that you create automatically becomes a type. You don't have to create it. You don't have to write struct anymore for it. Again, in here, if I have struct employee and I have over here size t, I mentioned what is size t, right? It's unsigned integer. M employee number and name and character M name with 60 characters. Why do I say 60 and I type 61? Who has the microphone? Who has the microphone? You have the microphone. I said name 60 and I type 61. You know why?
Yeah, for a null terminator.
Null termination. Thank you. Pass it the next one. So null termination is the reason. That's you need to remember. That's the definition of a C string. Please realize that a C string. We don't have anything called strings in C language. Remember that. We don't have anything called strings in C language. String is just a terminology that programmers use to tell to each other, I have a character array, and I'm going to end the data in that one with a null termination because I'm not sure how many I have. So you get the maximum size. You said name of a person cannot be more than 60 characters. So I'm going to put 61, and anybody's name is going to come in. I'm going to fill the name in that character array and end it with a null to show that it's ended. And that's standard. We call it a C string. And from now on, don't call it string. When you are in C language, you call string. When you come in OOP244, again, we are C++, we actually have something called string that is in OOP345, not 244. Please do not use C++ strings. We are only using C strings, but we always mention C at the beginning to convey the message that this is a null terminated array of characters. Again, interview question. Very simple stuff they're asking. What is a C string? You have to say it's a null terminated array of characters. Okay? Remember that. All right. Yeah, so to actually create an employee, all you need to do is now to say employee. Actually, let me change this. This was about oops, that was Alt F8. So that's I'm going to call it a array of pointers. Oh, actually 0, 1. Okay, bringing this back up. So in C language, to create an employee, you had to actually write the whole thing. We don't need to. Now, if I do this in front of an employee, you know what does it mean? It means size t will become 0, and all the elements of array will be set to 0. That's a good thing about it. You do like that, it just it quickly does it, so you don't have to worry about anything. That's the universal way of setting everything to its defaults. Okay, so now and that's how I'm creating an employee, and you can always, so I'm going to call it empty in employee E. In here, I'm going to put 1, 2, 3, 4, 5, and I'm going to call it Fred. Okay, and I do that. So that's an employee that I'm creating. Now, if you to write a function to actually print the employee, I can go void print. And in here, I'm going to say employee E. So you don't need to, I'm going to call it A, whatever, so an argument. So you don't have So you don't have to write struct anymore. It becomes a type. And we call these things a compound type. Essentially, that means, or a custom type. Same name, compound type, custom type. Type is a type that is made up of fundamental and other compound types. So if I have an employee over here, and an employee has something like a struct job, and this job has a character title, 80 characters, and double salary, my employee can have a job too. Right? You got it? So this is a compound type. Employee is a compound type too. They're all the same. And now I do it like this. It means that even job will be set to null all the way through. So now in here I have to do this Fred Soleil, and in here I have to say, I have to do it like this, and right over here what? Title teacher, salary is $1.22. Actually, let's do it like this, $10.22. All right, so something like that. And now it's all set. So essentially, this goes to first, this goes to second, and this goes to job. We good? Are we okay? All right. So if I want to actually print an employee, now I can actually do whatever I want to do. I have to say, I can say cout something like name is set to a dot name, cout ID, a dot employee number, cout job title will be a dot m job. You see, this is a good thing about m thingy. As soon as I say m, all the members coming out. So when you have lots of stuff in your, now it's only m, but when there are lots of stuff in your structure, it brings up the attributes very quickly. So job dot title and cout salary a dot m job dot. This code is okay. I don't know if, let's see if it's going to be okay or not. So, oh shoot, I forgot the column in here. Okay, so this works pretty fine. Okay, what is wrong with this code? Who has the microphone? What do you think is wrong with this code? It's working. It's one of those things that the student says, but it's working. Give me a second, 3 passes. But it's working. What is wrong with this? Any guess? And if not, just simply pass. Pass? Okay. Gentleman with a hoodie. What is wrong with this code? Good morning.
Sorry, my bad.
Okay, you can pass it. Pass it.
No, wait.
What is wrong with this
Try
code?
and answer it.
What is wrong with this code?
With this code, okay, I'll pass.
Okay.
I'll pass too.
We had 3 passes, right? Yeah, sure. Actually, microphone, please. Thank you. I know it takes more time, but it makes it more. Thank you.
The code is inefficient. Instead of passing the whole object, we can just pass pointer to the object.
Thank you. So, pass it. So, code is inefficient. Why? It's a ginormous thing. When I'm passing an employee over here, it copies the entire thing into the damn thing. 81 plus 8 plus 8 plus 61. Oh my God, it's lots of information over here being passed to be able to get printed. It's very inefficient. So what do? I can just do this. Actually, I forgot. We keep forgetting that we actually have overloading, right? So if I do this, I can actually write it like this. Correct? Are we good? What is wrong with this code? By the way, it works. Let me just put it over here. So I'm going to put them both. So I'm passing the address of E for the second one. Wait, yeah. Stupid compiler. Okay. Okay, so it works. So it's the same thing. It works, and it's going to show them both, as you see. But what is wrong with this code? Forgetting about this. What is wrong with this function? You can't answer anymore. I know you're craving to, but don't. Pass. Next one.
Pass. Pass.
Pass.
Anyone? What is wrong with this code?
I'm just gonna guess. Is there a more efficient way to print out the fields of this struct instead of writing it line by line?
No.
No?
That doesn't make any difference, actually. Good call, but that's not it.
Alright.
Anyone? Yes. Okay. You have a question. I know it's bothering to do something like that, but and the question is?
I don't understand line 15.
Line 15.
Where it says A.M job and then dot.
Yeah,
M. I don't
so
understand.
you know what is a dot for A? You have no problem with that.
Yeah.
But you have a problem with dot after M job,
Yeah. Why is it?
because M job is a structure of its own. Take a look at line number 3.
Okay.
Okay, this is Fardad's hat, right? This is Fardad's hat, right? This is Fardad's hat's microphone, 2 apostrophe S's. So the first one says, this is, remember, first of all, dot is an apostrophe S. Okay, Fardad's hat, okay? So in here I'm saying employee's job, correct? But that job has a title, employee's job's title, because a job has details too. So it can keep going. We good?
Yeah.
And thank you very much for the question. I really appreciate it. Okay, so anyone, what's wrong with this code?
Maybe we can use pointers for job as well.
No, then you need to know dynamic memory allocation, and you don't know it yet. Nice call, though. The answer was, can we use pointer for M jobs? M job. Anyone? What is the what print is supposed? What is print's job? I know it's a very stupid question, but what is print's job? What does print do? We'll go to the last pass. Okay. I like that. Yeah. All right. So, by the way, for those people who are listening to this, I have no idea what I'm saying when I say I like that. he had an awesome keyboard over here, left and right, and I'm like, yay, this is amazing. Anyways, keyboard at left and right, amazing. Because I like ergonomic keyboards. I have a broken wrist, so and I saw that it's awesome. Anyways, yeah.
A print function prints the attributes of employee.
Fantastic. So the job of print is to print, correct? I have a question. When you have a document on your computer and you print it, and when the printout comes out, does your computer's document change? It doesn't change, right?
Const. We should use const.
Yes. You have to always enforce the logic of what you're doing. So you have to always, if it was a read, it should have been a pointer. That's fine. But because it says print, you have to make sure that the person who's using print is not going to change anything in that thing. You have to enforce your business logic at all times. It is extremely important to do so. You have to protect you from yourself in future, where you actually want to debug this and you say, oh, the name doesn't have a space. Let me add a space over here afterwards and ruin the thing. You have to make sure you enforce always your business logic. Are we good? All right. I know it takes a long time. These are important stuff that I want you to know. So that's essentially what I wanted to say about compound types, so we know what they are. Auto keyboard, we talked about it, right? Declaration, definition, we talked about it. Which file declarations go to? If I have separate files for a module.
Header file?
Header file. Which file definitions go to? Usually?
.c.
CPP file.
Yeah.
.cpp file. Okay, good. Pass it through. Okay. So that's that. So scopes. What are scopes? Okay? I'm going through my cheat sheet over here to see if I have an example so I don't have to write it. No, we don't have it. Okay, so what is a scope? So first of all, this is compound type. Scopes. First of all, where did that scope go? Go away, give me a second. Scope, there you go. Okay. If you look at the notes, it says add existing item. We did have some kind of a module in the other one, right? Yeah, we had a student. I'm going to bring the student over here. By the way, if you are, it's an important thing. You see this? I want to add the student from another project in here. Don't just add it. Copy it in your own directory, then add it. You see, I'm copying it. I'm doing copy first. 3 years later, I'm doing copy first. Then I'll go back. I'll come to this place. I paste it. Then I add it. Okay, always remember that. Okay, now. You good? You okay? Everything's good? Shall we? Okay, all right. So, good, so I have something over here. I have a student in a header file, and I have some subject over here. And some, good. So I have stuff that I want. Now I'm going to come over here and actually add that student over here. So I'm going to say over here, include student. And I think we had a Seneca with there, right? Seneca, right? Yeah, we did. Okay. So this is my student now. I have a student over here, and I want to do something with it, whatever. Okay. Now, okay, scopes. I'm going to go the other way because I think that the way they mention it over there is wrong. First of all, you have no idea what global scope is because they were faking it. They were telling you global scope. I hate computers. And I'm teaching them because I keep teaching stuff that's important, and I see two people are looking at somebody's screen while I'm teaching. Close this goddamn stream, for heaven's sake, and listen. Okay. Scopes, in the notes, it's mentioning it from... You feel me now?
Yeah.
Okay. So it says global file function class block, where it's supposed to be the other way. First of all, block scope, okay? Block scope essentially is a variable that is defined inside the block. You see that? And it dies at the end of the block, and it gets recreated at the beginning of the block. That's number one, okay? Function scope is a variable that is created within a function. Now in here I have main, any function, okay? You may have noticed that I have two J's in here, one in inner block and the other one in an outer block, right? Inner block and outer block, you see that, right? In any scenario that you're going to learn from now till end of OOP244NBB, when any inner scope redeclares an outer scope's variable, it shadows it. It's not a mistake. It could be a bug, but it's not a syntax error, which means J inside for loop shadows the J outside of the for loop. When it comes back, the values of these J changing has nothing to do with the other one. It's not going to change the other. They're two different things. But this one has a function scope, the J, and this J has a block scope, okay? And it ends at the end of the block. Are we good with that? Okay. Because this is C++ 14 that we are teaching in here, there are things from C++ 17 and 20 that is new about scopes you're going to learn in 3, 4, 5. So if you hear stuff that I'm not mentioning it here, they're in C++ 17. We'll talk about it the next semester. Class scope is when you have a variable, a member variable. So these three have class scopes. Later on, when we learn what classes are, whatever that belongs to the class have access to all these. So if your class has any type of inner scope, they all have access to the class scope. So class scope variables are visible everywhere within the scope of the class. Are we okay with that? All right? We don't know still what class scopes are because we don't know what a class is. File scope is when you create a variable here. And if I'm going to call that integer passing grade. And I'm going to set that to 50. Okay? It's the exact same thing as equal to. I'm using it so you get used to it. So equal to that one, potatoes, potatoes. Okay? Remember that. It's as if I'm writing passing grade is equal to. That's file scope, which means it is only accessible inside the file and nowhere else. That's not global. Okay? That is not global. What number is common between students? Passing grade was common. So in here, I'm going to say integer number of subjects. I'm just coming up with nonsense stuff. Bear with me, okay? So now I have two file scope, right? But I want this passing grade to be available everywhere. I want to make it global, which means I want this to be accessible in the main too. Okay, if you want this function to be available in main, what did you do? You created this declaration in the header file, right? So essentially, in the header file, you added a prototype like that, correct? Therefore, in prg.cpp, you can actually call the reg. So if I say over here, reg something, it knows what it is. You see, it says Seneca student, yada, yada. It's telling me what it is. Okay? So reg is available here because you have a prototype in student.cpp. It's in student.header file, right? Now, I have news for you. You can actually create declarations for variables. This is a 3, 4, 5 concept, but it's necessary to tell you what global variables are. That's why I'm teaching you here. So this is one of the things that probably you don't have it in the notes. How do you create a prototype for a variable? You copy the variable name. You put it over here. And then you write over here, extern. That means in your header file, you are telling to any file who's including student.h, there is an integer called passing grade somewhere. Work with it. It is exactly like a prototype that you are writing a function. There is a function called reg somewhere. Work with it. So it does the same thing. If they change the passing grade, well, that passing grade changes. So this is global. Because of the extern in student.h. This is file scope. Scope visible to all file. Later on, you'll see we're gonna use this. So, for example, you see C in and C out. C in and C out are objects of type iStream and OStream. They are objects. Like you say, employee E, somebody in IOStream library wrote iStream C in, OStream C out, and instantiated it. So you can print and write, read and write. But because they wanted it to be accessible to you, we have extern iStream C in the IOStream header file and extern OStream C out in IOStream header file. That's why you can write C out everywhere. it's a global object that you can use. We good? All right. So those are the scopes. We are officially done. Okay, so this week's material is completely over, done through. Everything's covered. The next day you are coming in, we are going to talk about an extremely important topic called dynamic memory allocation. Okay? If you are missing the next lecture, you're going to suffer it for the rest of your life. So it's an extremely important thing to come to. It's 8 o'clock in the morning. Bring your coffees. Be awake. Okay? Good sleep the night before. And it's going to leak to the lab session too, definitely. Okay? Are we good? Have a good one. Come. Oh, can I have my microphone?
I see of the reflection is open back to